Professor Robert Aish is a visiting professor of design computation at the Bartlett School of Architecture, University College London. His research explores how computational representations, language, and tools can improve the way architecture is conceptualized and delivered. And this includes research on normalized geometric models of construction, parametric design tools, design computation languages, as we've seen today, and topology as a conceptual representation of architecture. Central to all this research is the recognition of a symbiotic relationship between computational design tool and design thinking. Should the development of computational design tools be constrained so that these are easily retrofitted to conventional design practices? This is a key research question. Or is the whole point of computational design to introduce new abstractions which can change the way designers think and define what can be built? It's another key question. This is on the link I shared a moment ago, and Professor Robert Aish's ResearchGate link is there as well.
Okay, I'd just like to welcome Dominic Orchard, who is the co-author of our paper, and he is a leading member of the programming language research community, and he's been guiding the development of this paper and the ideas. I also would very much appreciate the comment by, I don't know the name of the person, Mr. CODE at Aracon, but you've made some really interesting, Matthew, right, really great, really interesting response to our paper. And I think you raised some really, both the paper and your comments raised some very interesting issues, which is our visual, and this actually came up in the ACM SIGPlan conference that we gave the other paper to, because another paper at that conference was arguing that visual languages enable programming concepts to be presented to users, which are very difficult to express in conventional text-based languages. And so you can do things which you can't do with text-based languages. And as the example, the example we showed, which is slide 8, that really complex visual program, you can represent complexity in a way which a kind of linear or hierarchical text-based programming language can't do. But where does it get you? This is the problem, because you can express complexity so deeply that it becomes incomprehensible and it becomes unmanageable, and you can't translate it into text-based programming. So it leads you off into potentially a wilderness, a dead end. So that was the difference between, I think, my work on generative components and on DesignScript, where we realized that there was a limitation to visual programming. And although people could exploit visual programming, at some stage they had to come back to regular programming. And therefore, I think we've reformatted our ideas about visual programming as a lead-in, something which shouldn't introduce divergent ideas which cannot be expressed in text-based languages. But as you said, Grasshopper has become, which is sort of successor to generative components, has become very popular. But does it actually lead? Does it lead anywhere?
Right. Yeah.
Is Matthew got an answer? Would Matthew like to reply? Yeah.
Matthew, please feel free to switch your camera if you like to ask your questions. You can ask questions in the chat or directly by just talking to us.
Can I just say one thing, that I went to a user group meeting of a familiar visual programming language system. And I met there a very distinguished colleague who was one of the pioneers in computer-aided design. And at the end of the conference, he turned to me and said, there is no computer science here. And that really struck me. And I think what we have tried to do with Dominic and with Al Fisher is to try and put the computer science back into visual programming.
Right.
So sorry, Matthew, I cut you off.
So I'm
Matthew, you're muted.
so I'm trying to unmute
Sorry,
you.
hello.
Yeah,
Now we can hear you.
Yeah, sorry. What I was doing was probably a little bit rude, but I was like, I had the little Zoom test app because my microphone wasn't working, and then it started working in the middle of when you were talking, and I didn't understand that was maybe going to be recorded, but I apologize. I totally agree, right? So my history is, you know, I studied pure mathematics and learned programming there, and then I came to architecture in the AEC. And then, like, you know, the only programming that was happening was Grasshopper, right? And then, like, there's things about visual programming. I've written about this before. I'll send you the link in the chat as well. But like, that visual programming is in a weird way designed in order to like make actual programming more difficult, right? Because it's a bit like a capitalist thing. It's like, to be successful, I have to obfuscate all the things you're talking about. Like, and the more of those things I obfuscate, the more successful my programming language is, because it's like people don't have to think about this stuff. And it's like, it's really interesting being like, but what is the pedagogical process to get to being able to actually program, right? And it's like, yeah, you're like, everything's been designed in order to prevent people from getting better at programming, right? Because it's like in a weird way, the student market and like the novice person coming to programming, like, because the people that are attaching to visual programming languages are coming at it from they're not studying computer science, they're like studying something else, and it's like, well, this is easy for me to achieve the things that I want. So it's like, and this is like your diagram goes 1, 2, 3, 4, and it's like for me, the real interesting conversation is like, what's 0 to 1?
Yeah.
Right. And yeah, like, so it's like, because that's like, everything else makes sense. It's like that's perfect, right? Like, I would buy that. I would make that myself. But then, like, I know that the things that are at 1 are like working against us, and so yeah, I'm gonna clump myself into your, like, I've bought into what you're selling, in some sense. But it's like, it's the fact that those things are designed and they're successful because they resist the very thing that you're proposing, right? It's like,
they don't lead anywhere.
they don't lead anywhere by design, right?
Yeah, it's a lobster pot. It's easy to get into and impossible to get out of. And I would be interested in the audience response to our extension languages, because the paper is in 2 halves. One is arguing against for a reform of visual languages and their roles. And the second part of the paper is saying, and we can go further, leading up to conventional languages like C# and Python. And then we say, well, these languages didn't only go so far, and there's some interesting concepts which could be included in an extension language, which could help application programmers not have to constantly reinvent the wheel and make their programs much more semantic, like units of type, units of measurement types and interval types, and particularly the connected collections. So I just wonder whether there's any kind of feedback on that.
Right. Yeah.
Maybe Dominic has got.
Yeah,
like
I'll just add one very short, very small observation to that. I think that a lot of the things that we've thought about in terms of these extensions, it's about bringing the concepts in the domain into the language and actually being able to grapple and specify the key properties that are needed in architecture and engineering construction sector. And I think that the visual language traditionally don't give us hooks in to talk about those things as easily. So perhaps in that progressive formalization kind of style, we're going towards a space in which we find it easier to connect in those domain specific concepts and bring them into the language as first class things rather than something that's sort of shadow and second class and not really addressable.
And if I may say, going back to Matthew, I think that the way computing is taught in schools of architecture, if it allows people to go off into a dead end of visual programming, then it should be, it's not servicing the long-term interests of those users. And therefore it needs to be reformed. How many times do students create enormous grasshopper definitions, which they paste onto the wall, and nobody can understand them, and they're not critiqued, and there's no scrutiny, and yet they're pretty fundamental. I mean, Dominic teaches computer science at the university, and I can't imagine any of his students producing a program that was not in a form. It's not just the program, but the program's got to be in a form that it can be scrutinized by the tutors. And yet in architecture, we just say, oh, isn't this complicated? Isn't this beautiful? Oh, what kind of architecture do you produce? And the idea of programming as something precise and reviewable is just skipped over. You wouldn't do that with drawings, would you? With other representations in architecture. So why not with programs? So I think maybe it goes back to an educational thing, that you have to have more rigorous use of computing in architectural education.
And do you have any thoughts, Robert and Dominic, on things like educating neuroatypical students? Because, for example, dyslexic students, like architecture education and architectural training, do create a degree of dyslexia. We know that, like, for example, another example on education and the specialization of the brain is mathematical education. When it gets to a very advanced level, it increases your chances, or you certainly get the side effect of not being able to recognize facial expressions. So, yeah, so that's quite, especially post-PhD maths. So that part of the brain that deals with facial expressions recognitions, it's used for maths as well. And maths takes over to a degree. So that's quite interesting, because like very known architects, world famous architects, they are dyslexic. So how do you deal with that?
Well, first of all, I was quite dyslexic so I thank you for that. But one comment I heard from a colleague of mine was that programming is easier if your natural language is word ordered. So if your languages are not inflected languages, if you're are not so analogous to programming, to text-based programming languages.
Mm-hmm.
Yeah, I will say that I don't know particularly much about this area, and I do think it's an area that needs a lot more research. There's been really interesting work in the Netherlands with the Heidi programming language, which is a sort of it's a progressive language for education that starts off very natural language based, and has been and it's constructed in a way that you can hook into lots of different natural languages and ones that have different orders, like Arabic and things like this. So it gives people a way of kind of coming into it from their own linguistic basis, which I think is really interesting. But for those with dyslexia, I mean, I have observed that sometimes students with particular forms of dyslexia do struggle with programming. I think one thing we can do is work on the tooling, and IDEs already provide support and linking things together. And I think that there probably needs to be a lot more research on that, to be honest. But I don't know very much about it.
The other very interesting case that I came across recently, and it's someone I work with at my day job, is the fact that, of course, if you, in the autistic spectrum, let's say if you have Asperger's, you are a great programmer, Yeah, because it kind of, it gives you an advantage in programming. You often also have aphantasia. So you have the inability to manipulate imagery in the brain. And that's also very interesting because the visual programming interface becomes very obscure very quickly. And the dyslexia is not a problem whatsoever. And, you know, if anything, it's you're very coherent when you're reading and so forth. So I just wonder how those interfaces can have an impact on learning when you have this neurodiverse student community. I find this fascinating. I agree with you, Dominic. There is a lot of research that we need to develop in that area. So I would like to thank you very much
Thank you.
For this wonderful opening keynote. We do have a very short break. The break was supposed to be at 10:50. So maybe we can make this a tiny little shorter, have a 5 minutes break, and then you'll have our session 1 on design computation algorithms with Dr. Tim Wilkins. I will make an introduction when we open that session. So I'll just stop the recording for a moment and we can have like a 2-5 minutes break and then I'll come back and start the recording again. Yeah, I feel quite privileged to have this opening keynote. I think this is wonderful research and I'm very curious to see how this is going to interact with the advancements in AI. Yeah, thank you so much and I'll see you in a short moment.
Thank you.